everyone. This is the lecture 2 of the Water Gems tutorial series. Now, in this lecture, we are going to learn things which we should do before designing a hydraulic network. As a hydraulic modeler or as a water supply engineer, it will be your responsibility to visit the site and collect the data. Now, what happens is whenever you are in a college, so if you have a doubt, there will be people to solve it. So in colleges, most of your doubts, if at all you have, gets answered. When you go to master's level or PhD level, you are working in a domain which is very narrow. So there are very less people who can help you with those doubts. Similarly, when you go to job, so maybe people might be knowing the things which you want to do, but since you are a fresher, it's my personal experience and also the experience of hundreds of people whom I have talked to and whom I know that people generally don't help in companies. So your growth entirely depends on how much effort you put. And sometimes what happens is even if you put so much of effort, you can't learn things. So after watching this video, so many things which you will be learning at the end of 2 to 3 years of your experience, you can learn it after watching this video. So let's start. So this is a basic overview. Like what we are going to learn in this video is what are the various data that we need to collect, which is also called as preliminary data, before designing a water supply network. Okay, so moving on. So preliminary data required for a water distribution project. What all things it includes in it? Okay, so I will just give a reading so that you can have a little bit of idea, and then moving on we will discuss everything in great detail. So the first is population data, why it is used, where to get it from, everything we will discuss. Next is the existing hydraulic infrastructures. The next is existing mechanical, electrical and civil infrastructures. The municipal boundary, and if you are from India, you will be knowing the ward boundary, means a larger area is divided into smaller chunks. So in India, we call it as ward boundary. So you can check what it is called in your country. Again, next point is the assessment of the existing infrastructure. What is it? We will see. The next is the water quality data, existing supply data, problems associated with it, the revenue data, source study, existing road photographs, network drawing, schematics and process diagram, and the status of development of wards, minutes of meeting and survey data. Okay, so let's start one by one. So the first thing and the most important thing is population data. Okay, so why do we need population data? Revising it from our previous lecture is because we are designing the water resource or the water supply thing for a period of 30 years. So what is the population today may not be the population after 30 years, and it has chances that it will increase. So we need to get an estimate of how much it will increase. So how we estimate it? By having the previous data on our hand and plotting a curve which will tell us what will be the future forecasted population. Okay, basically it's extrapolating. So we can do it either graphically or by various methods prescribed by our course. Now here what we are going to learn is where do we collect the population data from. Okay, so overall or you can say majorly there are 4 sources from where you can get the population data. The first is the census website of your country. For India, we can get the population census data from the census website. You can just put the city, the district or the pin code of where you want the data. Okay, but there is a slight problem. Now the second thing is municipality. When you are designing, suppose you are designing a water supply network for Goa, okay, or some district of Goa. So now you go to the municipal corporation of that place or the Nagarpalika in smaller towns. So they will give you a municipal maintained data of the population of 2011, because currently we are in 2021 and this year census has not happened because of obvious reasons, that is the pandemic. So they will give you a municipality data of population data of 2011. Again, they will also give you a data of 2001, 1991 and most probably 1981 also. It may vary from place to place and country to country. Okay, you can also get this population data from the water resource department of your locality. In India, the water resource departments, along with that, we can also get the data from places called as Jal Sansthan and Jal Nigam. So these are the authentic sources from where we get the population data. Now, when they give you the data, so they might orally tell you that in 2001 this was the population, 1991 this was the population. So you need to get it documented. Okay, so you should have a proper format in which it should be an official format in which you should mention all the data and take the sign of the person who is giving you that data, because these are legal things. So you cannot just write things just because somebody has told you orally. So you need to write all those data and take a signature from him. So the format for that, we will discuss about it at the end of the video. Now moving on, this is a sample census data. Okay, so you can see that what was the population in 1956, 1966, moving on 2001. Okay, the next point that we are going to discuss is existing hydraulic infrastructure. Please forgive me for the mistake in the spelling of infrastructure. D should be removed. Okay, now what do I mean by existing hydraulic infrastructure? So in any city or any place where you are going to design or revive the water supply system, some infrastructure will be already existing. Okay, so our duty as a water resource engineer will be to locate and identify all those pipelines, all those water treatment plants, overhead tanks, ground level service reservoirs. Why we need to do that? Because when we are building a new network, so we don't discard all the older things. Okay, suppose a general life of an OHT is of 30 years. Now there is an OHT which has completed only 10 years. Okay, so 20 years life is still remaining, so we can use it for the 20 years. So if we have all the data about this OHT, so we can incorporate it in our new design. Okay, so for that, what all things we need is location, how to take the location at a point. You can use any GIS software, or you can also use Google Earth. And I'm planning to go on a site someday, and I will give you a live demonstration of how to collect a data. That will be very helpful. Then you can also get the MOC, that is material of construction. Some pipelines are constructed from iron, concrete. Similarly for tanks, you can see iron tanks somewhere, then concrete tanks, and similar. So you should know what are the various material of construction of the infrastructure that you are recording. Okay, this will be helpful because depending on the type of material, the design life may vary. Then the year of construction. Okay, so as a resource engineer, water resource engineer, you will have to take a call whether this OHT should be discarded or whether this pipeline should be discarded. So how you will do? First, you will visually inspect the things. So if it is looking that no, it's not usable anymore, you will discard it. Again, one other criteria can be that if it has completed its design life. In general, OHTs are designed for 30 years. So if it has completed 30 years, it can be discarded. Okay. Then you should also know its capacity. Why we should know its capacity? Because that will help you when you are integrating an existing design in the new design. Okay. Then the various problems associated with it, like where are the leakages, which all places are not getting water properly, and you can just talk to the various stakeholders such as local officials, or you can also conduct a door-to-door survey in 5 or 10 houses to get a clear picture. Okay. Moving on. Now we will talk about the existing electrical mechanical infrastructure. Now this is out of our scope. Okay, as a water resource engineer, we don't need to delve much in these things. But at times what happens is on site visits only you will be sent, or it may happen that electrical engineers and mechanical engineers may not be sent. So you may be alone or with some civil engineers. So in that case, you should have some basic idea that what we need to collect from the point of view of electrical and mechanical engineers. So vague idea is that first of all you should take the pictures of all the pump houses and the motors that are there, then all the electrical rooms and the transformers, etc. Okay. After that, you should also check the motor rating, the head, and all those things. Generally in any pump house, you will see a board where all the details are written. Okay, so you can take a snap of that and report it to the main office. Okay. So these are the things which you should have in mind. The next one is the assessment of existing infrastructure. Okay. So what do we mean by assessment of existing infrastructure? These are, again, this we have discussed already. There is one new point here. That's why we are discussing. First one is design year. If we know the design year and we know that the year of construction has completed the design year, we can discard it. Okay. Then we can also have some consultation with the stakeholders, such as local people, the people who are maintaining those overhead tanks, the pipelines. They will have a better idea whether it is working, either it is rusty, it is weird. Okay. In some cases, since you will be joining as a very young employee, a fresher, so you will not be having conclusive idea whether to discard an OHT or whether to discard a pipeline. So in that case, you take some good pictures from at various places and send it to the experts of your company, and they will provide you a detailed feedback. Okay. So this is how it is done. Next is municipal boundary and ward boundary. Now this is a very interesting point. Just have a look at this. Now in this, this is a place, Kolkata, located in the West Bengal state of India. Okay. So now you can see that this place is having an outer boundary, which is the municipal boundary of this city or this area, which is under our project scope. Again, you can see the various numbers. These numbers are the sub areas under the bigger area, which is called as ward. So when we go to these places to collect data, we should always get this data, where there should be a graph containing the outermost boundary along with the ward boundary. Now the problem is most of the offices here give you hard copy. Okay, like they will have the maps, but they will give you in paper format, and that becomes a headache because we have to work in water gems. Okay, and in water gems, if we are getting a hard copy of these things, so we cannot use it properly in the background of water gems, because we can obviously build networks on this and all, but if we want to get the elevation, the XYZ coordinates, then that will become a problem. So ask them if they have a KML file. KML file is the one which is supported by Google Earth, or if they have a AutoCAD file, whether in DWG or DXF, anything will do. Okay, if it's in DXF, well and good. If it is in DWG, we will convert into DXF. Now there can be cases when they don't have any digital format, they only have the paper one. In that case, what we will do is something which you all have read in your GIS lectures, that is georeferencing. In georeferencing, we try to digitize this entire image. Okay, so in a separate video I will teach you one day what is georeferencing and how to digitize any hard map. Okay, using QGIS or ArcGIS, any software which you want. Moving on to the next point, the existing supply data and the revenue data. Now, why do we need to know about the existing supply data and the revenue data? The existing supply data tells us about what is the demand, total demand of the place, and how much of that is getting fulfilled. Because if somebody has given you a contract to build a water supply network in that place, it means there is a shortfall of demand and supply. So you need to calculate that, and for that you need to have a existing supply data as well as existing demand data. So these things you can generally get it. Okay, by the way, coming back to the point, this ward and this municipal boundary data, you will get it from the municipal corporation or the Nagar Palika of your vicinity or the place where you are going to do the project. So just show them the letter of the project and they will provide you with all the data. Okay, so this is the place where you will collect it from. Talking about the existing supply data or the revenue data, this data you will get it from the water resource department of that area. In Indian places we call it that Jal Santhan or Jal Nigam. Okay, so you can visit these offices and they will happily give you all the data if they have. Okay, so this is how the revenue data and or the number or the demand data will look like. Okay, in this you can see that the total demand raised during the year, the total collection made during the year, again the number of connections, and there are various rates of supply of water. For this much of water you will have to pay this much. So everything, they will give you a budget that this much revenue is getting collected and this much expense the government has to bear. So you can also look at what solutions you can give to improve the revenue of that sector. Moving on to the next point, water quality data. Now, why do we need to collect the water quality data? It is for the simple reason is because if you are living in a place which is full of groundwater, okay, so when you extract groundwater, it needs very less treatment. Okay, so but how much treatment it needs, we need to know, na? So for that we want the water quality data. With water quality data, it checks all the parameters which we have read, like the pH, turbidity, chlorine, etc. So for the pro forma of water quality data, like the format which you need to have to collect this data is again will be discussed at the end of the video, that how can you can get that format for the collection of water quality data. And this is very important because in cases of surface water and all, you need to have a very clear picture of what quality of water is coming. Based on that, you will either give a WTP, that is water treatment plant, or you will, if the water is clean enough, you will give some filtration followed by chlorination and then supply the water. Okay, so this is very important. And as you can see that this is how it will look, the total dissolved solids, total hardness and all. They will give you everything, and then they will, at the end of that, they will give you a remark that whether your water is good for use, or if not, what kind of treatment it needs to have. Then one very important thing is source study. Now let's say that there is a place and somebody said that we need 200 mld of water after 30 years. Now we will have to check whether the groundwater is sufficient for supplying 200 mld, means 200 million liters of water per day. Okay, so for that we conduct some source studies. Now source studies can be of two types. We can either, if it is a surface source, we will check the current at the peak of seasons and then try to calculate the source, that if we take that much of water from that river or that stream, what effect will be there on the downstream. All right, again for underground water, we need to have a data on at what depth we are getting the groundwater. Okay, or we can also do some modeling so to predict the storage that is underneath the ground. So this is very important. Source study should be done. Generally these data is also available with the water resource department, or as I said in India, the Jal Nigam or the Jal Sansthan. Moving on, the next thing that we need to know is the existing roads. Okay, so why do we need to know about the existing roads? Simple reason, because when we will be laying the pipelines, that will be on the existing roads. Okay, so we need to have a brief idea that what is the width of the road, whether there is any encroachment on the road, and what is the material of construction. Okay, why do we need to know the width of the road? Because at times we need to provide two pipelines on the same road. Okay, so in that case we should have proper width of the road, then only it can be excavated and two pipelines can go. In hilly areas and all, you will see that the roads are very narrow. So there it becomes a very difficult problem to dig and bury the pipelines. Okay, then encroachments, what is visible or what is the survey data that we have received will give a very different picture, because the roads may be encroached by somebody or somebody may have constructed something. So all those things can be known only if we visit the site and take some pictures and send it to the team. Then the next thing is material of construction. Why do we need to know about the material of construction of the road? A very simple thing is because when you construct a water supply scheme, so there are roads already existing. So now when you are going to put a pipeline there, so first you will extract the road, you will put the pipeline, and then you will build the road again. Okay, so now you have to build the road with the same quality of material that it was built already. Example, in hilly areas you will see that they prefer concrete roads, RCC roads, but in plain areas we mostly prefer the bitumen roads. Okay, so while we are estimating the cost of the total project, we take this cost, that replacement of road. So if we know the type of roads and the length of those roads, we can have a better estimates of how much cost it is going to incur. The next thing, and again I will call this also as very important, is the existing drawings. Now existing drawings comprises of 2-3 things. The first thing is this one, that is the water supply network of the existing system. Okay, so you can get it from the supply departments of your state or the area. So in this we will have all the infrastructure such as pipelines or WTPs, OHTs, etc. And you can see various orange, red, blue lines. These are the various wards, how it has been distributed. Okay, so it gives us a very good schematic view of how the pipelines are laid and where are the pipelines, because if we are going to excavate something, we should know where the pipeline is already existing, otherwise it increases the cost and the work. Okay, the next thing is this process flow diagram of the either the water treatment plant or the STP in case of sewage. This we need to know, because if a water treatment plant is there which is newly constructed, but we need to construct the water supply network of the city again. So we are bound to use this WTP. Okay, for using this WTP, we should know the process flow diagram, how much capacity it is catering, where is the inlet point, where is the outlet point. All these things should be known. So for that, we need to get the existing diagram of this place. The next thing is the status of development of wards and area. Okay, what is this? Again, my same line I will say, this is also important. Now consider this place. This is a place in Maharashtra. Now you will see that the right side of this place is having a very dense population growth. Then in the middle you will see very less, and then in the northern side you will see very less population. Okay, so what happens is, and why do we need to know this diversity in population? Because if we are designing a population forecast or a water supply scheme and we need to do the population forecast, so the area in yellow on the right side, it has very limited growth of, it has very limited potential of growth. So here the method that we can apply is maybe the arithmetic mean method. Okay, and other areas which you can see, we can apply the methods which gives us a higher return value of population. Okay, so here you learned a new concept that if you are designing a water supply network for an area, necessarily we don't need to give the same factors for the entire area, because if some area is very highly developed already, so it has very less growth of potential. Okay, but if an area has very less growth, then chances are high that it will grow at a very larger place from the nearby occupied areas. Okay, so for that we need to know this trend. Now this can be received either from the Google Earth image of the area which you are going to construct a project on, or you can also have a discussion with the various stakeholders about which wards are developed, which wards are not developed, and which have more scope of development. Generally it is seen that in the middle area the places are developed, however in the outskirts there is a chance for expansion. Okay, so we will work accordingly and arrive at a conclusion, and this we are going to discuss in great detail in our next lecture, which will be about population projection and demand calculation. Now this is again a very important thing, that is the minutes of meeting. Now when you are visiting for data purposes in any office, so what happens is there will be things that they will say orally. Okay, and there will be data that they will give. There will be some meetings that will happen in which various things will be discussed. So as a water resource engineer, you need to be legally aware also. Okay, so whatever has been said, whatever data you have received, you need to note down everything in a minute of meeting. Okay, you need to minutize all those meetings, the people who were present, what all things were discussed. Okay, and then you need to take a signature of all the people who are attending the meeting, so that nothing is vague anymore. Okay, everything that you have discussed, every data that you have collected is properly documented, and at the end of the project you put every minutes of meeting at the end of your detailed project report. So this is very important, and the official format of a minute of meeting we will discuss at the end of this video. You can use that format and it will be very helpful. Again, you can also make your own format, but since I have the experience and I know what all things are required, so what I will provide might be helpful for you. Next thing is survey data. Okay, now this is something which we will not do, the third party will do. Who is the third party? The people who are good at surveying. The entire area that you are going to supply water for, they will conduct field experiments on the entire area. What all data they will collect and what all data they will give us? They will give us the road network. Where are roads? What kind of roads? Okay, so based on that we will calculate the length of pipeline, because we will be generally putting pipelines on all the roads unless and until specified by the client. Okay, then the next thing is location of important landmarks. They will also give you the important landmarks, the places in the city that they will mention in the survey. They will also give the levels of various places. Okay, levels, why do we need the levels? You know, because to design it we need to know the levels so that we can calculate the head and flow. Next thing is the number of houses, the pattern of houses, trees, etc. Some idea we will get from this also, and these all things we will get from the third party survey that will happen. Again, the various infrastructures such as where are the various OHTs located and these things. Now once we receive this data, they will give these data generally in the form of a AutoCAD file format, or maybe they can give some shape file. So when they give it to you, now you can use this data directly as the background of your WaterGems file. So now you have X, Y, Z, the road networks. You can simply start drawing the network. So job becomes easy and accuracy is also good. So this was the last thing. Again, at times we need to collect the geological data also. Why do we need to collect the geological data? Because if we are going to bury a pipeline in a city or in a road, now we need to know what is the underlying strata under that road, because if it is a hard rock, we need to give a different treatment. And obviously we can also not go very deep in if it's a hard line, okay, hard rock lying. Apart from the things that we have discussed, we can also cover this in 3 more headings, and the first among the lot is bulk demand points. Now what are bulk demand points? Any industry, college, hospital, or any big settlements in your residential setup which requires more amount of water per capita. Okay, so now why it is important to consider such things? The simple reason is that if we don't keep a demand at the place where it is located, the demands will be distributed in an average manner. So that will give us a very incorrect size of pipes that is passing through that area. Okay, so if in WaterGems we keep all the bulk demand points at the exact same place where it is located in the real field, so then this will erase this problem and give us a correct estimate. The next point is development plan of the city. Now we are designing something for 30 years and more than that. So we should know how the city is going to change in the next 30 years. What are the various government plans, schemes, what residential areas are going to get built, what industries are coming, and so on. So this data about the development plan of the city, we can get it from a town planning office or an urban development office, that what is their master plan for the next 20 or 30 years. Now using this we can incorporate our model by the inputs given from the development plan. The next and the last thing is land availability. Now why do we need to know about land availability? There can be cases when we need to construct a water treatment plant. Now let's say we need to make a water treatment plant of 10 MLD. 10 MLD water treatment plant might need a certain amount of land. Now to give and check all the hydraulic conditions, we need to know where the land is located and how much land is there, so that we can locate the same on our WaterGems and check the hydraulic conditions. Okay, so for that we need to know the area of land, the location, the dimensions, and layout. I hope you liked the content. You can subscribe this channel if you want to watch the remaining lectures of the WaterGems series. Comment below if you have any doubts or if you want to say something about us. Okay, and don't forget to like the video. Thanks and have a nice day.